All right, so what we're gonna do is try to simplify a motor control circuit. So we seem to be having some issues with understanding the motor control circuit. So I like to describe that as a sentence. Our motor control circuit, the most simple circuit is going to consist of a hot, we're going to call it line 1, and it is also our power. Whatever you want to call it, whatever makes you feel warm and happy on the inside. We're going to make that be our conductor. And our motor control circuit consists of a normally closed push button. Normally closed, that's going to control our power. Then we also need another button that is normally open. Then we also need a holding contact. And then we need coil. So this system, we're just gonna, whatever, 120 volt, single phase control circuit. So then if it's 120 volt control circuit, our coil is rated at that voltage. Then we also need another wire that is our neutral. And because it's our neutral, that makes it also our line 2. A lot of people tend to have issues with this right here. Now, neutral can be a line, but it is definitely our line, our return. So the black represents equipment. This is going to represent conductor. So what we're going to have is we're going to have a combination circuit. During our electrical theory, we learned about series and parallel circuits. So what we're going to do is we're going to apply that information and that knowledge here. So what we do is we take our power, which is in parallel with our entire control circuit, right? So we're going to make our first connection here. And this is going to represent, a connection point. Yeah, connection is not spelled out all the way because I didn't want to get into my conductor. So from our line coming in to our stop, let's do this. Stop. This is our start. This is our holding contact. And this is our coil of our contact. And then another thing is a lot of people don't realize that this is the same piece of equipment. They look at the piece of equipment, but when they go to wire it up and you see them two in two separate spots, it's kind of hard to tell what's going on with that guy. So in our stop, and for the ease of installation, 1, 2, 1, 2, 1, 2, 1, 2, A1, and A2. Typically, you're going to see that on all contactors that you buy. Typically. So, right there, we're controlling our hot coming in. This connection here, we're going to just take it. Now, like I said, this is the very most basic one because we don't have any overload protection. We're going to say that this guy is thermally protected. And we're going to make our connection from here to there. And it's done. Connection point. Right now, if we hit any of these buttons, we don't have a complete circuit to our coil. So then now, we need to create a parallel connection. And just for the ease of seeing it, I'm going to go this way, just to exaggerate the parallel connection so that you can see that. Then, and remember, this is another area of concern when students see this. A lot of times it's not drawn like that, but I did that for a connection point so you can see you need a wire to go from here to there, and also a wire to go from here to there. This is one, two, 3 points connecting. You need a wire to connect here, here, and there. And that's just showing you for ease that they are connected together. So now what we have is a complete circuit here. And if we were to use our meter and take our voltage, with these being our probe, and we take a voltage reading from here to here, we'll see that we have open condition, and we know that across our open you have maximum voltage, right? So we're coming through, we have our hot, we got power flowing here, but we have an open. Our power is also continuing flowing there. You have to push this to now create a close, which will energize the coil. And another thing that people don't seem to really grasp, a lot of people say that you close the contact to energize the coil. If you look at, in essence, what you have, and this happens simultaneously, because we understand that you must energize the coil in order to close the contact. The contact does not close based off of you pushing that button and providing voltage just to that node of a dry contact. Holding contact, the other term is dry contact. We are providing the voltage there. So, what we have, once we push that button, I'm going to show that now. We're going to make contact there. All right, because I'm going to show contact. Everything there, I'm going to draw it the same way. And what we have is a closed contact. And if we were to bring our power in, and this is our neutral, this is our hot, Now look what you have. You have nothing, you have no resistance to the flow of current outside of the actual use of it, so don't kill me by saying you have no resistance, because there is resistance in every piece of equipment. But you have your coil that now has 120 volts across the coil of the contactor, which is on. Alright. This normally open contact is now closed. It is not normally closed. This is normally open in its de-energized state. The way you read this schematic, this is the way you would see it if someone wants you to wire it up. This would be how these pieces of equipment are in its de-energized state. It's shelf state, the way it is when you just pick it up in your hand. This switch should be normally closed. This switch should be normally open. You can have an auxiliary contact. You could, I don't want to say you must be this, but what we have here is we're showing typically a contactor that has an open contact that pulls in once you provide voltage to that coil. So this is now closed, but it's momentary because it will pop back up once you release it. And the reason why this is called holding, because you have bypassed. If you look at what you did here, you're bypassing this hot and it's going through, bypassing this push button with the hot. So if you were to take this guy out, if you notice what you have here, you have a connection, a wire that's connected here. It's making its connection here, going through, connected here. Now look at what we're doing here. It's still there, but see it's open, that's open. The power flows through because through this guy, because you're getting this through your close. When you close it, boom, simultaneous. You energize it and that activates the bypass. That's your bypass. Energize, activate the bypass. And that's it in a nutshell. Just have to, and if, no one noticed. Oh no. My mind is thinking of two stops because I looked at this. This is your momentary switch. So that's it in a nutshell.